Hello everyone, my name is Aaron Dennis and this is my workshop video number 3 for CSC-381. Just like my previous 2 workshop videos, I'll be covering Dead by Daylight, sort of building off those earlier 2 videos. And I'll be doing a deterministic Turing decider. And I'm not going to have time to cover the sort of the game recap or the DFA. If you would like to see those, please go check out those previous 2 videos. Like I said, they're on my channel. I'm not going to cover the PDA either, but I will point out what I was looking to improve on the video number 3 here. So first of all, this relationship, I had it before where the power was kind of like meaningless. It was just like there was like an input for the power being turned on, like that was one of my characters here, and then that would just automatically bring you to this final accept state, and there was really no like rhyme or reason for why that was happening. And I wanted to sort of make it make more sense. So like once the survivor completes a generator, that contributes towards it, and once they've completed enough generators, it'll automatically turn on the power and reach that accept state. So that's what I wanted to do. And I also wanted to have, you can see I kind of statically hard coded in 3 lives. I also kind of wanted that to be variable so that, you know, if there was a different sort of situation where maybe you have a bigger game or a bigger map, or you want to make it more challenging, you can sort of change the number of lives and also maybe change the number of generators for this part up there too. So we'll see how it works more later. Before I get into the JFlap demo, I will go over the alphabet. Again, the only changes were from before were that I took out the P for the power coming on because that's going to be handled automatically. And I'm just going to use this X and Y. Again, these are similar to how I used X in the PDA where that was part of the stack alphabet, but this time they are actually part of the X and Y are both part of the input alphabet. And so it's going to let the player or whoever's using the machine, basically, it's going to determine, okay, how many lives do you want to initialize with and how many generators you want to initialize with. Tape alphabet is the same as the input alphabet. It's a proper subset, except there's these 2 additional characters here. Obviously, the blank character just signifies the end of the tape. And then the Z character, we'll see more later how I use it to track where I am at in reading the input. Moving on to the language, I'm not going to cover this regular expression. Again, I'm just kind of going to be running short on time by the end of this, and it doesn't really, it's kind of trivial, I guess. So let's just use the English version, the higher level version. It makes more sense anyways. We'll say the language is the set of strings A, where A such that A begins with 0 or more X's followed by 0 or more Y's, followed by a valid sequence of other inputs resulting in a winner of the game being determined. So a couple of things I would like to point out with this. First of all, a winner of the game being determined, meaning it's not going to say who won, it's just going to say did someone win, or from the perspective of the survivor, it's not going to say did you win or lose. It's not going to say win or lose, it's going to say yes or no, right? Also, you might be wondering 0 or more X's, like what if it needs to determine a winner of the game, how is that the case? If there's 0 lives or 0 generators, that it would be impossible to determine a winner. That's because, as I said here, the X's and Y's are actually the number of extras. So like you automatically start with 1. So that's just like something to keep in mind. And then the final thing that I wanted to point out was the input string has to begin with this whole thing, basically, meaning there can be extra characters added onto the end. Now, the reason for that is because Turing machines always halt once they reach an accept state. So long as a winner is determined or decided, then at that point, it will halt, and it doesn't matter if there's extra characters on the end. So I think that's pretty much will give us a good base for the walking through the JFlap demo. I'm not sure what the best way of covering this is, but I have a test input here that kind of that has sort of that covers all the transitions. So we'll just go over it really quick. And I think I'll just do a step by state. Again, we start out by reading 0 or more X's and then 0 or more Y's. And so the first, I guess, initialization part of the game is just going to be focused on this left side of right, like these states right here. And so what it's going to do is it's going to move basically those Y's down to the other side and get that input string exactly how we want it. So it's going to sort of read in the X's, store those in memory, then read in the Y's and store those in memory, basically. So here you can watch it do that. It's going to take those Y's right there and move them down to the other end, and then sort of shift everything down just to keep the input string together. Here you can see it moves the other one down. And now after this, right here, now we'll be focused on the gameplay section of it. So it'll be all on this side. And there's only a few possibilities of what can happen. First of all, again, this is kind of the same as before, but if the survivor is trying to evade the killer, one of two things can happen. In this example, they were successful, so they moved back to the lurking state. In the next example, they were not successful, and what's going to happen here is it's going to go back towards the end, and it's going to look in memory and see, are there any lives remaining, basically. If so, it will take one away, and then we'll just continue to play the game. If not, it'll end the game. In this case, it's going to go back all the way to the end. It does see a life there, so it's going to take it away. And then it's going to use those Z's to remember where it was at along that tape, and then it's just going to continue to read input after that point. Another possibility is if the survivor tries to fix a generator. Again, one of two things, they could either success or failure. If they fail, they move to the evade state because they alert the killer of their position. And so then, again, one of two things, right? So they could lose another life. In this case, they don't. They try to fix another generator. If they're successful, it's going to move. You can see along the tape here, it moves along to the other side, goes to check a different place in memory for the, and it, same thing. If it sees a Y there, it's going to take it away. And if not, then it realizes that all the generators have been completed, and then the game would be over and the survivors would win. So that's pretty much all the transitions here. I'm going to go a little bit faster throughout this next part. You can see it looks like another generator was completed there, and then there's more gameplay. It looks like here, another example of a life being lost, and then it's going to come back and finish it out. Now, this last time when it goes and looks for the lives, there's none left, and so it instantly ends. And as you can see, that one worked out pretty good. And one thing I would just like to include, I'm going to do a couple more of these just to show you guys. So what would happen if, say we had some extra lives at the beginning, really we only need like one, and then we had maybe at the end a situation where additional generators were maybe completed. That would result in the survivors winning. Again, same process as before. Remove those Y's down to the other side. This is just to sort of initialize the game and move along here. Just sticking on this left side until we reach the gameplay portion of the game. And here we go. It's the same input string as before. That's why I'm kind of going through this kind of fast. Yeah, I think it's so helpful if you just look at watch as I'm stepping along here, and you can see exactly how the machine is sort of manipulating all those. And it's really helpful. And it's kind of how I learned all this stuff, honestly. So here you can see it's still going through and processing the input. It's using those Z characters to track exactly where it left off. Here, it was like the same as before, and then these are like the changes from what I just made. So we had that extra life, so that did not end the game that time. And now, if we're reading a generator, we look back, and this time we don't see any Y's at the end. So that also ends the game. there's no really determination. It doesn't tell you which team won or whatever, but it does, you know, transition to that final accept state. Also, just want to point out, like I said earlier, it doesn't matter if there's extra characters there because the machine halts instantly upon reaching that accept state. Couple more inputs, guys. Just bear with me here through these. Oh, if we had no X's, what would happen is it would just kind of step over. It wouldn't really read any in, and it would just start working on those Y's, moving them to the other end of the tape. And this time, this is why this transition is here, just to handle this case, I guess, that middle transition there. And then in this example here, the game is going to end really fast because we only have our base life. We don't have any extras. So as soon as we move back to the gameplay portion here and we get hooked, it's going to look and see if there's any lives left, and there's not. So this is an instance where the killer won right away, and it'll just move to that accept state, and that's the end of the game. Just a couple more, guys. We got same thing. If there's, instead of if there were no X's, if there were no Y's, what would happen, just to make sure that it works. And yeah, it basically doesn't need, I'm sorry, it read in the X's, and it didn't need to move any of the Y's down to the other end. So then it just instantly basically starts reading gameplay, right? And so one of the things that it'll do is once it takes away that life right away, and then once the generator is completed, again, same thing. It's going to look down at the other end, but there's nothing there, so it's just going to move right to the accept state, right? And then the last two here that I want to cover is if, say we had an additional life, and I don't want to make this super long, so I'm going to kind of cut this off. What if we just had all these lives, and then, you know, I guess that was, I just want to show this. If we go through the initialization part and everything is good, and then we did not determine a winner, and I could have basically left that whole string and just added one more X and Y, but I didn't want to like skip through this like a billion times. So I just want to show here, like, what'll happen is basically now you can see it has read all of its stuff, and there it went to failure because there were still X's and Y's, and all the other characters had already been read. And then the last one, just to prove, say we had a random character somewhere in here, say a U, for instance. I should not have done that. If we had just because it'll take too long, guys. If we had like an unrecognized character, essentially, that wasn't part of the alphabet, it'll reject as well, obviously. That brings us to the end of the JFlap demo. I did implement this in C++. I don't have enough time to walk through this step by step. I will just say it's not an exact equivalent, like, to the, or I guess it doesn't work the same as the deterministic Turing machine or decider that I built. However, it is exactly equivalent because if you enter, again, the same input string as before, it will reach game over, and that's essentially means an accept state. Likewise, we're going to do basically the same inputs here. If we had an additional couple of lives, and then at the end we maybe completed a couple more generators, this time the opposite, the survivors would win instead of losing. But again, it really doesn't matter who wins or loses. It just matters that we can get to that game over. What were the other ones? Oh, if we had no X's, really short game again, but it is a valid input still. And same with the Y's. I'll just do it really quick. Yep, works, game over. And then the only other two that we have to cover here really quick is Yeah, again, this will give you a good example. So here we have additional x's and additional y's. Basically this, and we know this gameplay is not gonna take away all the lives or take away all the generators. So at the end, it's gonna kind of just be left there doing nothing. And then here we do not reach game over. We get an error message printed out there. And then again, the last one, this time I'll put it in the middle. Random character doesn't accept it. So guys, that wraps up my entire workshop series. Honestly, I had really enjoyed working on all of these videos and building all of these machines and stuff like that. Thank you guys so much for taking the time to watch these all the way through. I hope you were able to learn something or at least found it interesting. So thank you again and have a great day, guys. Goodbye.